Okay, so as you know, the Nano initiative in Vanguard, it gathers a lot of regions from Europe that have initiatives and interest in micro, nano technologies, new materials, and new developments for the industry. The objective is to get a community of institutions collaborating in projects with high TRL, with impact in the industry, gathering interest in different technologies. And for that, there are some projects, pilot projects that are presented, and we work together to try to push them into real solutions. So any of the regions of this initiative is welcome to propose ideas and to join objectives to move forward in different solutions. NAITEC is a technological center in Navarra, one of the regions that is part of this Nano-Pilot in Vanguard. We are located in 3 different buildings. We offer solutions to develop more competitive and sustainable products and processes. We are oriented to work with the industry. And these are different multidisciplinary knowledge that we work with. We are divided in these 6 different areas. And the solution we propose for this pilot project, motivation is the growing sector of composite materials and the structural health monitoring, because every day there are more applications that require live monitoring of health in different facilities, such as wind turbines, automotive, or hydrogen storage. This is a very, very competitive market that is growing in the recent years, and the future is expected that will grow, as you can see in this graph. We are proposing 2 different solutions for offering structural health monitoring in this type of structures that can be applied for hydrogen storage or wind turbines. One approach is using optical tags on the surface. We use nanostructure surfaces that should be visible to perform optical measurements. The advantage of this type of solution is that it doesn't require any wiring in the object that we are monitoring. The measurement can be performed with a certain distance, and there is no electrical current on the surface. So, for example, hydrogen storage or some corrosive or explosive environments can benefit of this type of light-based technologies. And the second solution that we are proposing is RF printed tags, because we have a lot of experience in printed electronics. We started working on an approach with completely passive tags. This allows a certain measurement characteristics, but we are now studying embedding some small components, having active tags in the composites to have improved performance of these tags. We're still trying to minimize the components to affect the minimum possible to the structure of the composite. For this, in NAITEC, we have long experience in nanofabrication since 2008. We have 2 class 10,000 laboratories, laser interference, nanolithography, electroplating, and all the equipment to fabricate low-cost periodically nanostructured surfaces. This offers the possibility of measuring deformation by light diffraction or also by plasmonic effects. And we have a long experience in this type of nanostructuring surfaces and materials, and we are very focused on reducing the cost of production. These are examples of the different applications that we have worked with the years in this type of periodic nanostructures. And also for the printed electronic solution, We also have a lot of experience in this field. We have a pilot plant with flexography, gravure skin printing, inkjet printing. We have worked in formulation of conductive inks for 2D and 3D printing technologies. And also, not only the materials, but also the devices, a long experience printing, designing, characterizing devices on 2D and 3D printed electronics. You can see a few examples there. 2D heaters printed on a textile. You can see a horn antenna printed with a conductive filament with a 3D printer. And on the right bottom corner, an example of the capabilities that we have to incorporate active printed electronics into 3D parts with the new system that we have. And with combining these technologies, we will offer solutions to monitorize the formation inside the composite materials. We would like to collaborate with other institutions that will be interested in textile technology with the composite materials. Also, some of the possible collaborators that will work on developing readers, and then also final application in hydrogen storage, aerospace, and we are open to collaborate. So this is